Good afternoon, students. So, today we'll do states of matter. Already in our class we have done it. What is matter? What are the different states of matter? That is the three states of matter basically we are having it: solid, liquid and gas. Another two states also we are having is that is plasma state and Bose-Einstein's condensate. So, but our topic of discussion will be upon the three states, that is solid, liquid and gases. Now, the thing is that what makes or what factors makes the difference between the solid, liquid and gas? The first question is what factor that is governs or it makes the difference between a solid, liquid and a gas? Now the next question is that what are the properties by which we can say that this is solid, this is liquid and this is gas? To understand this particular thing, the first question I said, what are the factors which that governs a solid, liquid and gas? So the matter is made up of solid, liquid and gas. Now it's a very simple example I'll give you. We'll start with that particular example only. That if you see ice, it is in the solid state. Water, it is in the liquid state. And water vapor, is it in the gaseous state. Fine. Now, what we find is that every matter is made up of the kinetic molecular theory of matter says that every matter is made up of there is small particle, atoms, ions and molecules. Every atom is made up of, we know that actually. Now you know that these atoms, ions and molecules, they are never at rest. They are always in a state of random motion. Now for this I have told you in your class this particular thing, that how do we know that the atom is in random motion? We have seen the Brownian motion. Alright, if you have forgotten it, once again let me tell you what is a Brownian motion. For Brownian motion, Robert Brown was an English biologist. What he did is that he took a beaker, he put some lycopodium powder, or you may put pollen grains also into it. Okay, and what it is that just stir it once. Now after that you observe it through microscope. When you observe it through microscope, you will find that the pollen grains, that is the molecules of the pollen grains or the particles of the pollen grains or the particles of the lycopodium powder, it strikes the particles of the water and it shows a random zigzag motion. This sort of motion you will be getting it, a random zigzag path, and this path it continues for any length of time. Means suppose for example you are seeing it for 1 minute. Now after 1 hour again you are seeing it, you are also seeing the same thing. You observe the same thing, that the particles are still in motion. The particles are still, they are colliding with one another and they are in a random motion. Got it? So if you see after again say 1 hour or 2 hours, you will find that the particle continues to be the same thing. That means we can say that the particles are never at rest, they are always in a state of random motion. Okay. So kinetic molecular theory says that the particles are never at rest, they are always in a state of random motion. That means they collide with one another. Now why? Because they have got some kinetic energy. Due to the presence of kinetic energy, what we find is that the molecules are never at rest. Because you know that what is kinetic energy? The energy possessed by a body in motion is known as kinetic energy. So hence these molecules are in motion. So hence they have got some kinetic energy. So hence they are never at rest. They are always in a state of random motion. Fine. Now what we find, the next point is that the molecules are in a state of random motion. They are moving with one another because they possess some kinetic energy. Now the third point is that with increase in temperature, the kinetic energy of the molecules increases. As temperature increases, kinetic energy also increases. As temperature increases, kinetic energy also increases. Now how do we know that as temperature increases, kinetic energy of the molecules increases? Very simple. What it is that you take some water and you boil that particular water. You increase the temperature. What you will find is that the molecules move rapidly. They collide with one another rapidly. After some time you will find that the water vaporizes. It starts boiling and it vaporizes. When it vaporizes, you will find the vapors it comes out. What is that vapor? It's nothing but the water vapor. Water vapor means it contains the energetic molecules of the water. Now these energetic molecules, what happens is that when you are increasing the temperature, initially it was held together by certain intermolecular force of attraction. Now when you are increasing the temperature, this intermolecular force of attraction decreases. Now when the temperature increases still further, then what happens is that the intermolecular force of attraction decreases to a certain extent that it cannot hold the water molecules together. As such, they leave the surface of the water. We can say that. So hence, we can say that as the temperature increases, kinetic energy also increases. We'll see it further in the chapter. Much more examples I'll give you in the further when I'll teach you. Next, after that, so as we see that the temperature increases, the kinetic energy also increases. Now, what we find that, as I said you, the molecules are held together by certain intermolecular forces of attraction. Now, what is this intermolecular force of attraction which is holding the molecules together? That is called as force of cohesion, or it is also known as cohesive force. Now, remember that there are two kinds of forces. Now, what is that? One is between the two similar kind of molecules, that is called as cohesive force, and one is between two dissimilar kind of molecules, that is called as adhesive force. Now, how do I explain it? You can take a very simple example. You take a glass and you put some water into it. Now, water and water molecules, remember it, water and water molecules is held together by force of cohesion. We can say that because they are similar. So two similar molecules are held together by cohesive force, that is called as cohesion. Now, what you do is that you just throw the water in the basin. You will see still some water droplets sticks to the surface of the glass. Alright, listen carefully. You will see still some water droplets sticks to the surface of the glass. What is that? That is nothing but the force of adhesion, that is called as adhesive forces. So when the force exists between two different kind of molecules, it is called adhesion or adhesive force. Alright, and when the force exists between two similar kind of molecules, it is known as force of cohesion. Got it? So in this way, these are the certain factors I said you. Got it? Which makes the difference between solid, liquid and gas. Now, how we differentiate? Now the question is, okay, we understood the factors. Now how do we differentiate, or based upon these factors we differentiate the solid, liquid and a gas? Now in case of solid, the atoms or the ions or the molecules are strongly held together. Alright, they are strongly held, closely held, I should say that. So it has got a very strong intermolecular force of attraction. And what about the kinetic energy? The kinetic energy is the least. In case of solid, the kinetic energy is the least. We can say why? Because the molecules are very close to each other. Alright, the intermolecular space is the least in case of solids. Why? Because the intermolecular force of attraction is the maximum. Okay. Now in case of gas, what do you find? In case of gas, the intermolecular, that is force of attraction, is negligible. It is minimum. We can say that. Means the molecules are far apart from one another. Far apart from one another. Why it is far apart from one another? Because kinetic energy is maximum. So what you find in case of gas, the kinetic energy is maximum and intermolecular force of attraction is negligible. It is minimum because intermolecular space is maximum. Okay. Now what about liquid? Now in case of liquid, what you find is that the intermolecular force of attraction, it lies between that of solid and that of gas. In solid, the intermolecular force of attraction is maximum, and in case of gas it is negligible. So in case of liquid, what we find is that there is some intermolecular force of attraction. There is some intermolecular force of attraction. But intermolecular force of attraction is not so, what you can say, large enough so that it will hold the, what you can say, liquid molecules in its position. For that purpose, what you find is that liquids do not have a definite shape. It takes the shape of the container. Alright, what I said you, in case of liquid, the intermolecular force of attraction is not so strong enough so that it will hold the liquid molecules at its position. Alright, at its position. So hence, what you find is that in case of liquid, for that particular purpose, they take the shape of the container in which it is kept. But in case of solid, what you find is that as they have got very strong intermolecular force of attraction, the kinetic energy is minimum. For that purpose, they have a definite shape. But in case of gases, the intermolecular force of attraction is minimum. The intermolecular space is maximum. For that purpose, the gas can flow in any direction. It can flow in any direction. But in case of liquids, it flows from higher level to lower level. We can say that in case of liquids. So what do you conclude then? In case of liquids, the intermolecular force of attraction is less than that of, what you can say, solids, but more than that of gases. But the kinetic energy, what you say is that it is also more than that of, what you can say, that is liquid, as more than that of solid. The kinetic energy of the liquid molecules, you can say that. Okay. Now one more point I will add it here, that in case of solid you can have large number of free surface. As you can see this pen, here it has got all the surface are free, it is free. But in case of liquid, suppose you are taking a liquid, you are putting in a glass, the upper surface is only free because the rest of the surface is bounded. But a gas does not have any free surface. A gas is always kept in a closed container, so neither of the surface is free, all the surfaces are bounded. So gas have got no free surfaces, liquid have got only upper surface free, and solids have n number of free surfaces. Any number of free surfaces a solid can have, we can say that. Okay, fine. Now next is, what we find is that the solids, they have got a large density for that particular reason. What I said, the intermolecular force of attraction in case of solid is, that is maximum, so the volume is the least. Because the molecules are tightly held together. The molecules very tightly, it is closer to each other, very very close. Alright, so hence what we find is that volume is the least. So density, you know, density is equal to mass by volume. So density is inversely proportional to volume. So volume is least, density is maximum. So in case of a solid, the density is the maximum. In case of a gas, the density is the minimum. So gases are lighter for that reason. Why? Because it has got large intermolecular space. So volume is maximum, so density is minimum. So gases have got the least density. Solids have got the minimum density, we can say that. And liquids, that I said you, it has a density in between the solid and that of the gas, we can say that. Now next is, the gaseous molecules are easily diffusible. They can easily diffuse into one another. How can we say that? Suppose your mother is cooking something in the kitchen. You are sitting in a drawing room. You smell it. Alright, after some time, the smell comes and you smell it. Or suppose when you burn an incense stick, an agarbatti, alright, in your room, in any corner of the room, after some time you smell it, that yes, some smell is coming. Why? Because the gas molecule diffuse into one another. But suppose if I keep this pen in any corner of the room, will you know it? No, because the solid molecule does not diffuse. Why does not it diffuse? Because in case of solid, same thing, it has got least intermolecular space. How the molecules will move into one another, how they will get attracted to one another. So in case of solids, the diffusion is the least, we can say that. For that reason, it has been seen that experiment was done that if you take a gold plate and a lead plate, it was kept for 20 years under huge pressure. One gold plate and lead plate, it was seen that hardly 0.001 millimeter of gold has diffused into lead after 20 years. So it is quite, what you can say, negligible, we can say that. Gases are highly diffusible, and liquids, they can diffuse into one another. For example, you take some water and you put a few drops of ink, you will find that after some time the color of the water becomes the same thing as that of the ink, because the ink molecule diffuse in the water molecule, we can say that. So liquids can be diffusible, gases is diffusible, but for solid they do not diffuse at all. So for that particular purpose also we can say the solids are not at all compressible. Suppose if I apply some pressure on the solids, can I compress it? No. But liquids, they are compressible to a certain extent, and gases, they are highly compressible. For that particular purpose, if you take 1 ml of a gas, you can keep in a 50 ml container also, and you can what you can say that 1 ml of the gas, you can squeeze it and you can bring it to point, what you can say, 1 ml also, you can do that. For that particular purpose, you have heard it, the word LPG, liquefied petroleum gas, in your home. That is the gas which is being filled inside the cylinder, it is being liquefied, because under high pressure it is being filled. When you fill the gas under high pressure, then it gets liquefied. So gases are highly compressible, because in case of a gas, there are large intermolecular spaces. So by applying the pressure, you can bring it closer to each other. Alright, so gases are highly compressible, liquids are compressible, but solids are not at all compressible, we can say that. Clear? So in this way, we can differentiate the solid, liquid and gases on the basis of this particular factors, on the basis of this kinetic molecular theory. I hope you have understood this. Thank you.